Hey everyone, welcome to another video. Today we're going to be talking about estimating and rounding positive integers. So this is probably the second last topic we're going to be doing in our entire topic with this operations is adding, subtracting, multiplying, dividing of positive integers. And what we're talking about here is rounding numbers and estimating numbers. Now, this is quite an important thing just in everyday use because we actually do this rounding off more in our heads than we may realize in day-to-day life. So I'm going to try to get through a lot of topics in this. It may be a longer video, but I want to hopefully cram all of this into one video and give you a really good, thorough understanding of this. Now, you may be wondering why I have this photo on my slide here. Now, this is a photo taken from the AFL Grand Final this year. So AFL is the national sport of Australia, where I'm from, and every year we have the Grand Final. So at the end of the tournament, we have this really big spectacle. There's a Grand Final, and it gets played at a stadium called the MCG in Melbourne. So this is probably a lot of background random information you may not need to know or it won't be relevant to you if you watch AFL. But you can see from the picture I've shown here, this is a pretty packed out stadium, right? You can see there's like heaps of people all over these stands here, and it goes all the way around. Now, this is one of the biggest ovals in Australia, one of the biggest grounds, and this is where the grand final gets played every year. Now, if I were to ask you, how many people do you think are here? Well, chances are you're not going to give me an exact number. You're going to say, well, I reckon there's 100,000, 327 people. No, you're not really going to do that. If they counted the tickets, they'd be able to tell us an exact number. But you look at this, you go, damn, there's a lot of people here. Or if you were in attendance, you would say, oh, there's quite a bit. There's about 100,000 people here. Now that about or roughly 100,000 people, that's what we mean when we talk about rounding. Rounding numbers is an approximation. We're saying there are roughly or approximately let's say 100,000 people here. So that's what I'd probably say. And if you look at news reports from this particular final, a lot of the time they mention, roughly 100,000 people, because this gives us an idea of the general scale of it, how big this is, say compared to a school assembly or any other smaller gathering. We get a sense of the size without going into the specifics. This is the essence of rounding numbers, because here we thought of us as rounding whatever the attendance was to the nearest 100,000. Now let's look at this a little bit more closely and look at how we'd actually round numbers. Now, I talked before that anytime we put a number, we thought of any number. So for example, 4,142. We split these numbers up into various columns. Now, we had, if you remember, our ones, we had our tens, we had our hundreds column, and here in this case, we have a thousands column. So all of our numbers can be broken up into columns, sort of where each digit sits. So from 0 to 10, we're thinking of the ones column. From 10 to 100, we're thinking of the tens, and so on and so forth. So as my number gets bigger, we're adding numbers to these columns here. Now, if I took this number 4,142 and I wanted to round it to the nearest 10. So I've specified a certain degree of accuracy here. I want to round this to something in this column. So not exactly accurate, but just rounded to the nearest 10. Now, what I'm going to do when I consider that, I want to look at the next digit to the right of the 10. So the smaller digit. So I want to look at this one here. And I want to say, when I round this, I'm always going to round this either up or down. And that digit's just going to become 0 because we're rounding to the nearest 10, for example. So whatever number we get to, you can have 10 going into that. So, for example, and how we do this is, I'm going to write it over, let's write it down here actually. So we can say, we first look at the next digit. So if I'm rounding to the nearest 10, we're going to look at the digit to the right of it. So this 2. And then we're going to consider the value of that. So if my digit is less than 5, this little symbol just means less than. We'll talk about that a lot more. We're going to round down. And let's move this down a little more. Sorry about that, guys. Formatting's a bit off. And if the digit is 5 or more, we want to round up. So let's actually look at what this means within the context of this question. So we have the number 4,100 and what did I put? 42. Let's make it 62. Just I'll explain why in a second. So here we're looking at, if we're doing to the nearest 10, we first have to identify the number in the tens column. And this here is a 6. And what we then do, we want to look at the digit to the right of it. Now, 2 is less than 5. So that means we're going to round down. So the nearest 10 to 62 is going to be, if I look at going up in tens, so for example, 10, 20, 30, 40, 50, 60, 70, what's closer to 62? Is it 70 or 60? Well, you can see 62, if I were to write it on a number line from 60 all the way to 70, 62 is about here. So it's a lot closer to 60. And that's what we do when we round. So this to the nearest 10 would be 4,160 because I'm getting it to the nearest 10 here. Now, what if I wanted to round it? So question B, we round to the nearest 100. Okay, now I'm going to take my number, 4,162, and I'm going to look at the number in my hundreds column. Now that's going to be this bad boy here. So I have my number in my hundreds column and I want to look at, well, what's the next digit to that? And that here is a 6. Now in this case, 6 is greater than or equal to 5. So we're going to round up here. Now, once again, we're looking at to the nearest hundreds. So, we have 100, 200, 300, 400. We're looking in terms of these hundreds. And just to help you visualize this again, a number line of 100 to 200, along this line, these are all the numbers from 100 to 200 condensed into this line. if we look at the number 162, well, halfway here is 150. So 162 is about here. If I were to round it, we can say it's closer to 200 than it is to 100. So that's why we look at this idea of 5 and above, as the 5 is always the midpoint. So if we're there or greater than it, our number, if we approximate it, is going to be closer to the 100, in this case, above than the one below. So it's closer to 200 here. So when we round this up to the nearest 100, I'm going to get 4,200. I'm rounding. Very sorry about that. I'm rounding up here. Now, let's look at how this applies to our multiplications or any operations we're doing here. Now, what we're going to do here is we're not going to be as specific as we were before. We're going to look to round here. We're going to estimate with our operations here. So I'm going to give you 3 questions, and we're going to first look at rounding, and then we're going to try to do our operation and get a number that's going to be roughly close to the answer. Because remember, in this video, we're just estimating. So let's say we have question 1, 42 times 7. And I'm going to find this answer by rounding each number to the leading digit. Now, what I mean by the leading digit is the first digit in each of these numbers. So my 4 here, my 7 here, these are my leading digits. They're pretty much just the highest of the digits in my number. So for example, for this one, my leading digit was my 4, the number in my thousands column. But here, I'm going to round to the nearest leading digit, and then I'm going to multiply this to get roughly an approximate answer for this. So my 42, we're going to round to the nearest 10. And my 7 is just one digit, so we're just going to round it to the nearest 1. So it's not going to change at all. Now, if I round 42 to the nearest 10, well, I want to look at my number to the right of it. Now, 2 is less than 5, but we're going to round down. 42 is closer to 40 than it is to 50. So to the nearest 10, we're going to round this to 40. And timesing by 7, as we said, 7 doesn't change because it's already in the ones column. To the nearest 1, I'm just going to round it to whatever that number is. So now that we have this, let me center it a little bit. 40 times 7. Now, I'm going to, some of you may remember, I can use the distributive law here. And this is really just extra practice for some of you, but I can break this 40 up into 40. Oh, sorry, not the distributive law. I'm using it would be the commutative or associative law, one of those couple. But if I times these together, this is like saying, well, 40 times 7. So I can break this up into, say, 10 times 4. And I know from my times tables that 7 times 4 gives me 28. So that's like saying 28 times 10. And then, well, if I times by 10, I can just think of just adding this 0 down at the end. When we times by 10, it's actually really easy to times by 10 or 100 or whatever, because we're just going to add this 0 to the end of the number. So I'm taking 10 lots of 28, or 28 lots of 10, that gives me 280. Now, we'll try a couple more. And here, I'm going to give you two more questions. Question 2, we have 115 times 92. But here, I'm going to estimate this by rounding both numbers to the nearest 100. Okay, so let's take a little bit of extra time to look at this. I have my number 115 and I have my number 92. Now, let's think of this 92 for a second, because we're talking about the hundreds, right? So we're looking at a number in the hundreds column. Now, 92, it has a number in the tens column and a number in the ones column. What number do you think is going to be in my hundreds column? Well, there's no number in my hundreds column. So we can think of, how do we represent nothing mathematically? Well, we can use the number 0. So I haven't changed the fact that this is 92, but I just added a 0 to show that this is 92 with a 0 in the hundreds column. It means the same thing. So 115, I'm rounding to the nearest 100. So I have my digit here in my hundreds column, and the one next to it is less than 5. So I'm going to round down. When I do 115, I round it. I'm going to round down to the nearest 100, which is going to be 100. Sorry, I forgot the multiplication here. So 115 is closer to 100 than it is to 200. We're rounding to the nearest 100. Now, looking at the next number, we have a 0 in the hundreds column, but the next number, the 9, is greater than 5. So that means that we're going to be rounding up. So we can think of this as 92. Is it closer to 0 or 100? Well, doing it to the nearest 100 brings us up, because 9, this second digit, is greater than 5. So in essence, we just get 100 times 100. And this thing here, we end up with 10,000. We have 4 zeros here. We're timesing 100 by 100. 1 by 1 gives me this, and then I'm just going to add in these zeros from here. So this is a rough approximation. Obviously, if we did our methods for multiplication, we would get a far more accurate number, but we rounded both of these numbers first to the nearest 100. So 10,000 is like a rough ballpark. That's what estimation's all about. We just want to be in the ballpark, right? Now, we'll do one more question here. And this is, I want to do 2,266 divided by 9. And I want to first find this by rounding both numbers to the nearest 10. Okay, so what I'm going to do here is I want to consider the nearest 10. Now that's going to be this digit here. And well, 9 is just a number in the ones column, but we can imagine a 0 here being in the tens column. So that's going to tell us how we want to round. Now, I'm going to, for this first term, the number next to it, number next to the one in my tens column, is greater than 5. So hopefully by now we get the idea. We're going to round up. So 2,270. And 9 rounded to the nearest 10, well, to the right of my number in my tens column, I have a number greater than 5. So I'm going to round up. So I'm going to get 10 here. So once I get to here, I'm trying to roughly divide 2,270 by 10. Let me just do my short division just to practice this because I talked about this in the last video. 2270. I want to divide this. So 10 goes into 22. Well, sorry, first, how many times does 10 go into 2? Well, it goes 0 times because 2 is smaller than 10. How many times does 10 go into 22? So now we're looking at, goes into it 0 times with a remainder of 2. So now we're just looking at how many times it goes into 22. That's going to be 2 times, right? With a remainder of 2. Now we want to see how many times does 10 go into 27. Well, it goes in there another 2 times with a remainder of 7. So the difference between 20 and 27 is 7. So that number is going to go up here. And then I'm finding finally how many times does 10 go into 70. If you remember our 10 times tables, 10 goes into 70 7 times. So let's just quickly recap what we've done here. When we want to round, we are finding an approximation. We're not finding the exact number. We're doing this practice of the field analogy, the AFL field analogy, this oval, where we say there's roughly this many people here. We're saying these calculations, first when we round, we say that, for example, 4,162 is roughly 4,200. It's close-ish to 2,400 when we round to the nearest hundred. And now when we actually compute these, when we do our operations, we can round both of our numbers to a certain degree of accuracy that we choose. And then from there, we can just say, what does this roughly end up being? 115 times 92, when you round both numbers to the nearest hundred, that just gives us roughly 10,000. Now, when we divided these, sometimes when we just want a rough answer, we can think of rounding this, estimating our answer roughly, and we go, okay, cool. When we divide 2,266 by 9, we get roughly 227. It's not the exact answer, but once you pop it into your calculator, you'll see whatever the answer is, you get kind of close to it by approximating, by doing this rounding first. Now, this is how we can make some multiplication, division, our other operations slightly easier. And it's important to note we don't get our exact answer. We get an answer that's pretty close. And rounding, we're going to see that happening a lot more as we go through school. So this idea is going to come up a lot more. So hopefully you got a good understanding of it in this video. And in the next video, we're going to talk about order of operations, and that will bring an end to this topic. Thanks so much for watching, guys. I'll see you next time.